Alrighty, today we're taking a look at question 4 for recitation 12. And for this one, we're trying to find the work required to change the capacitance of a variable capacitor, right? So it's going to be changing from 0 to 180 degrees. We're changing from 1,000 to 100 picofarads, right? So when we start, we have our C equals Q over V, right? Because we're just given the initial capacitance, that's 1,000 picofarads, right? And it's connected to a 500 volt source. So we're going to start by finding this charge, right? So 1,000 picofarads is 1,000 times 10 to the negative 12th regular farads. I just keep it in base units because it's easier to work with. So if we finagle around this expression over here, we get C times V is going to equal our Q, right? So we have our capacitance, we have our voltage up here, and so we're going to do Q equals capacitance 1,000 times 10 to the negative 12th times our 500 volts, and that's going to give us a charge of 5 times 10 to the negative 7 coulombs, right? So now we have the charge of our system, and then when we disconnect it from it's disconnected from the source, so it's not being charged anymore. So now when we change our capacitance, that's just going to be changing our potential, and that's what's going to change our potential energy. And we know that negative delta U is our work, right? So if we can find our initial potential energy and our final potential energy, we can use that to calculate the work. So the potential energy of a capacitor is going to be given by Q squared over 2 times the capacitance, right? So if we have our initial Q, we have the Q that we're starting with here. It's not going to change. The only thing we're changing is this capacitance down here. So if we're making this our delta U, it's going to be Q squared, which isn't changing for either, divided by 2, our initial capacitance, our final capacitance minus our initial, sorry. There's our 2C initial. And again, the initial and final charges are going to stay the same. So now if we're plugging into this, because again, delta is just final minus initial, so we plug everything in, we have our Q squared, 5 times 10 to the negative 7 squared, divided by 2 times our capacitance, our final capacitance, and we're changing it to, when it's at 0 degrees, it's going to be at 100 picofarads, which is 100 times 10 to the negative 12th farads, right? And we're subtracting, again, our second part, which is just going to be 5 times 10 to the negative 7th squared, because again, it's the same charge, divided by 2 times the capacitance that we started with, which we were given before was the 1,000, 10 to the negative 12th, right? So we're going to evaluate this expression, and that's going to give us some negative number, and then we're going to multiply that by -1 to get our work, because again, it's opposite to get work. Alright, so I hope you found this video at least a little bit helpful. Let me know if you have any more questions about this or any other problems that you want me to try to explain, because I guess Sydney explains stuff.